Welcome to this explainer. Today, we're pulling back the curtain on artificial intelligence. We're going to look at the hidden language that powers pretty much everything, from the chatbots you talk to the systems that generate complex code. You've been there, right? You ask an AI a seemingly simple question, and what you get back is just bizarre. It's nonsensical, or it starts repeating itself, or it just completely misses the point. So why does that happen? Well, the secret to all that weirdness isn't really in the words we see on the screen. It's hidden in the AI's own language. And that language is built out of these tiny little things called tokens, invisible building blocks where everything can go perfectly right, or, as we'll see, very, very wrong. Okay, so let's get into it. How do AIs actually read the stuff we type? Well, it all kicks off with this absolutely crucial first step. Before a large language model can even begin to process your prompt, it has to chop it up into smaller, manageable pieces. That process is called tokenization. You can think of it as translating our human sentences into a language the machine can actually work with. This Lego analogy is honestly a perfect way to picture it. When we write a sentence, we see the whole thing. The finished Lego castle, right? But the AI doesn't see the castle at all. It only sees the individual bricks, the words, the punctuation, even parts of words. And from that pile of bricks, it has to figure out what to build next. But here's the catch. Not all of those Lego bricks are the same. Some are for building the model, and others are more like secret instructions for the builder. So on one hand, you have your normal tokens. These are the bricks that make up the actual content, words like explain or gravity. But on the other hand, you have special tokens. These are totally different. They're like little markers that tell the AI how to behave, things that signal the beginning of a conversation or the end of a thought. They're basically the hidden command. And if you look at a real-world model like Llama 3, you can see these things in action. They're like stagey directions in a play. You've got a token that screams, hey, the prompt starts here, and other tokens that define who's talking. Is this the user, the system, or the AI assistant? These are absolutely essential for keeping the whole conversation organized. So what happens when the tokenizer creates a broken brick, a malformed piece? Well, this is where it gets really interesting, because this is the source of so much of the weird AI behavior we see. Researchers actually have a name for this, a glitch token. It's an anomalous token that the model just doesn't understand. For whatever reason, it's an outlier, and it can completely throw off the AI's ability to figure out what it's supposed to be doing. Let's look at a real example from some research on this. A user asks about the Nitrome, which is a game studio. The tokenizer correctly splits this into 3 clean tokens, the, night, and Rome. The AI gets it, no problem, and gives a totally relevant answer. But watch this. With one tiny change, just removing the space between the and Nitrome, the tokenizer creates a single, unfamiliar token, the Nitrome. The AI has never seen this brick before. It has no idea what it means. Its comprehension completely breaks down, and it just outputs a random paragraph about curry. Seriously, that's a glitch token in action. And these glitch tokens can cause a whole bunch of strange symptoms. You might get spelling mistakes or just a jumble of random characters. The model might just give up entirely and refuse to answer. That's called incapacity. Or, like we just saw with the curry, it might engage in hallucinatory completion, which is really just a fancy way of saying it starts making things up. So, this is the crucial part. These token quirks aren't just funny little technical glitches. They have very real consequences, affecting everything from the AI's performance to the actual dollars and cents it costs to run these things. This whole idea might actually feel familiar. Have you ever been typing a text, you've got plenty of characters left, but then you add a single emoji, and suddenly your character limit just tanks? Ever wonder why that is? Well, a standard text message uses the super efficient encoding system that allows for 160 characters. All the basic letters and numbers you use fit perfectly into this system. But the moment you add a character that isn't in that simple set, like an emoji, the whole system has to change gears. And your character limit plummets to just 70. That's because your phone has to switch to a much heavier encoding standard just to handle that one complex character. All of a sudden, every single character in your message, even the simple ones, takes up more than double the space. The exact same thing happens with AI tokens. Some tokens, especially for rare words or weird characters, are heavier than others. They take up more space in the AI's memory, which limits how much it can process. And since many AI services charge you by the token, these heavier tokens can literally cost you more money. So how are these tokens even created? Well, most models use this really clever process called byte-pair encoding. Basically, they scan billions of words and find the most common pair of characters, say T and H. The algorithm then merges them into a brand new single token, the. Then it scans the text again for the next most common pair, merges that, and just keeps repeating this process over and over until it has built an entire vocabulary of the most efficient tokens for that language. Okay, so let's zoom out and put this all together. Why does this invisible foundation of AI actually matter to any of us? I think it really comes down to three main takeaways. First, tokens are the absolute fundamental building blocks of AI language. Second, a lot of that weird, unpredictable AI behavior we see is caused by these malformed glitch tokens. And finally, and this is a big one, the way our text gets tokenized directly impacts the cost, the speed, and the accuracy of any AI model we use. So at the end of the day, this isn't just about technical jargon. If you want to truly understand the power and the limitations of AI, you have to understand the token layer. It's where the raw potential of these massive models meets the messy, complicated reality of human language. And all this leaves us with a pretty profound question to think about. If the very foundation of artificial intelligence is this sensitive, where a single missing space can completely derail the entire system, what does that really mean for our quest to build truly robust, reliable, and intelligent machines?